A company makes toys for children. Figure 5 shows the design for a solid toy that looks like a piece of cheese. The toy is modelled so that face ABC, that's the one you can see on top, is a sector of a circle with radius r centimetres and centre A. The angle BAC is 0.8 radians. Again, you can see that on the diagram. Faces ABC and DEF are congruent, so it's a prism-like structure with the top and the bottom being the same. Edges AD, CF and BE are perpendicular to faces ABC and DEF. Edges AD, CF and BE have a length of 8 centimetres. Again, that is marked on the diagram. We're given that the volume of the toy is 240 cubic centimetres. We want to show the surface area of the toy, S, is given by S is equal to 0.8 r squared plus 1680 over r, making your method clear. So, we mentioned it's a prism-like structure. So, if we can work out the area of the end, which is a sector of a circle, and then multiply it by h, we should get the volume. But we know that that volume is equal to 240. The area of the end with the angle in radians is a half times r squared times theta. In this case, the theta is 0.8. And then we need to multiply that by the height, area of the end times the height. So 240 is 0.4 r squared h, which means that h is equal to 240 over 0.4 r squared. And 240 divided by 0.4 is 600. So h is equal to 600 divided by r squared. Let's just stop with that one there. We're after the surface area. Let's think about what the surface is made of. We've already discussed the top, and the bottom will be the same as that. So that's going to be 2 lots of a half times r squared times 0.8. So that's ABC and DEF dealt with. Then we have 2 of these rectangles. We can see that those are r long and h wide. So that's going to be 2RH, and we also have the surface just here, which has an arc. That arc is of length r theta, since we're working in radians, so that's going to be 0.8 r times the height. So that gives us, well, the first term, this term just here, gives us 0.8 r squared, the 2 and the half just cancelling, and that is the first term of what we're trying to show. Then we have 2.8 RH. Note there's no h here, but we can replace the h with this expression up here. So that's going to be 0.8 r squared plus 2.8 r times 600 divided by r squared, and that does in fact simplify to 1680 over r. So we have the 0.8 r squared plus 1680 over r. We now want to find the value of r for which S has a stationary point. So we're going to do ds dr. Now note that we can write S as 0.8 r squared plus 1680 r to the negative 1. So that's going to give me 1.6 r. Take away 1680 r to the negative 2. And for a stationary point, we want that to be equal to 0. So we can say 1.6 r is equal to 1680 over r squared. And rearranging that gives us r cubed is 1680 divided by 1.6. So we have 1680 divided by 1.6. It's 1050. So r cubed is 1050. And then r will be the cube root of 1050. So cube root of the last answer is 10.2 centimeters if we work to 3 significant figures. Now in part C, we want to prove by further differentiation that this is a minimum. So we can do d2s dr squared, which means we need to differentiate this again. And that's going to give me 1.6 plus 2 times 1680. So 2 times 1680, which is 3360 r to the negative 3. And that is greater than 0 when r is equal to 10.2. And that implies that we get a minimum.